All right, we got topic 8.6. We are doing our first geometric proofs. Remember, in a proof, you're going to have some given information. You're going to be asked to prove something. In geometric proofs, you might have a picture to work with. Quite often you will. Remember, we're writing two-column proofs, so you're going to have a statements column and a reasons column. We always start with a given information because we got to start with something we know. And when we write that here, the reason will be because it's given. The last step, whatever step number that ends up being, is always what you were trying to prove. Because as soon as you provide a good reason for that being true, then you've proven what you were supposed to prove. Your job is done. You're going to stop. And make sure you don't write the word prove over here as a reason. They told you to prove it. That's what you need to prove. That doesn't make it a good reason for it to be true. Okay? So do not write the word prove over here for a reason ever. Okay? The given statements or known facts, conditions of the problem. What we'll prove is the statement to be proven. Diagram is just a drawing or picture of the problem. Statements go on the left side of the proof. Numbered statements that follow logically from the previous statement. Reasons, right side of proof. There are numbered statements that support the facts written on the statement side, developed from the given definitions, postulates, theorems discussed previous to the problem. So we're just going to work through the problem one logical step at a time. And every step that we take, we have to provide a good reason for why we're allowed to do that step, why we're able to make that statement. Quick review on some of the things that are going to be pretty common in these. Remember, a midpoint is the point right in the middle of a segment. It always splits the segment into two congruent parts. The bisector always splits something into two congruent parts. So whether it's bisecting a segment or bisecting an angle, it's going to split it in two congruent parts. Supplementary means that two angles that add up to equal 180 degrees. Make sure it's not an 180 degree angle. It's two angles that add up to 180. Complementary means they add up to 90 degrees. Remember that vertical angles are congruent. And here's some things you can determine from a picture. So don't forget your segment addition postulate. If you have a bigger segment that's split into two smaller parts, if you add those parts together, it equals the whole. Angle addition postulate, same concept. If you have an angle, we split it into two smaller angles. Those two smaller angles add up to equal the original big angle. Vertical angles, you should be able to recognize those in the picture, and they're congruent. Linear pairs, you should be able to recognize those in the picture. And remember, linear pairs are supplementary. So that was just a quick recap of what a proof is and some of the things we're going to use in these proofs. Let's dive in and start trying to actually do some proofs. All right. So on example 1, it's given to us that line AM bisects line segment CD. Okay, now remember that word bisect means it splits it into two congruent parts. It's going to go right through the midpoint in this case. So if this is bisecting line segment CD, then that means line segment CD is being split into two congruent parts. Now we're supposed to prove that line segment CM is congruent to line segment MD. Notice I already marked them congruent because that's what I always do when I read that word bisect. I know it splits something into two congruent parts. I mark those two parts congruent. So you'll notice it's a short proof. We always start with the given information. So I'm going to start by saying that line AM bisects line segment CD because that was given to us. That's how I know that that's true. And then if I know that line AM is bisecting line segment CD, then I know that line segment CM is congruent to line segment MD. That's why I marked them congruent. Now what do I write for a reason there? Well, the reason I knew they were congruent is because of this word right here, and because I know what bisect means. So it was based on the definition of bisects. It was based on the definition of bisect. Bisect means split into two congruent parts. So I know these two parts are congruent because that's what bisect means. All right, let's look at the second proof. All right, it says the distance from A to B is equal to the distance from B to C. So I'm going to go ahead and mark those congruent to each other. And then we want to say that the distance from A to B plus the distance from C to D equals the distance from B to D. That's what we want to prove. So we always start with the given information. So I know this is true because it was given to me. Now, when I see this, the first thing I think of, two segments adding up to equal one segment, is the first thing I think of is the segment addition postulate, where if I take a segment and split it into two parts, those parts add up to equal the whole. Notice line segment BD is being split into two parts by C. So I got line segment BC and CD. And those two parts would add up to equal that whole thing. Now, that's not the same statement, but I noticed that that's true. I'm going to go ahead and write that down because I think that's going to get me somewhere. The distance from B to C plus the distance from C to D equals that whole thing, the distance from B to D. And that's based on the segment addition postulate. All right. Now my goal is to say that this is true. Now we have the advantage here of having the boxes pre-laid out for us. So I already know this is going to be the last step. And what we're trying to prove always goes in the last step. Well, how can I get from the information I already have to saying that the distance from A to B plus the distance from C to D equals the distance from B to D? You should notice a lot of similarities between this statement and this one. The only thing that changed is right here. Everything else stayed the same, right? So, how can I replace the distance from B to C with the distance from A to B? Well, remember, they were equal to each other, right? And if two things are equal to each other, you can replace one with the other. And that's called substitution. So we can come up with this statement by substituting the distance from A to B in place of the distance from B to C. So we are using the substitution property. And we're done with our proof. We've given a good reason for what it was we were supposed to prove, so we have proven it now. Let's look at the next one. All right. So we got a picture over here. This tells us A is perpendicular to C. So that's line A is perpendicular to line C. Line B is perpendicular to line C. And we want to prove that angle 1 is congruent to angle 2. Alright, for some of us, it's pretty quick to see that that's the truth. But when we're writing a proof, we got to make sure that we don't skip any steps and just jump straight to what we know is true. We have to lay this out one step at a time and prove that it's true. So, we always start with some given information. So, I know line A is perpendicular to line C because that was given to me. Now, what does perpendicular mean? Perpendicular means that those two lines are going to intersect to form right angles. So, right here where I got line A and line C intersecting, notice one of the angles it creates is angle 1. I know that's going to be a right angle. So I'm going to write that in. Angle 1 is a right angle. And that was based on the definition of perpendicular. It's because I know what perpendicular means that I know that angle 1 has to be a right angle. Okay, now I also know that line B is perpendicular to line C. Again, because that was given to me. And just like I did on the other scenario, because I know that these two lines are perpendicular, I know that angle 2 is going to be a right angle. So angle 2 is a right angle. And again, that's because of the definition of perpendicular. Now my goal is to prove that angle 1 and angle 2 are congruent. If I know angle 1 is a right angle, and I know angle 2 is a right angle, they must have the same measure, equal measures, right? So angle 1 is congruent to angle 2. Now the tricky thing here would be, what do I write for a reason? If you just said all right angles are congruent to each other, that would work. If you happen to remember the name for the theorem, this is the name. Right angles congruence theorem. all right angles are congruent to each other because every single right angle is 90 degrees. They're all the same measure, so they're congruent to each other. Right angles congruence theorem. All right, let's look at the next one. All right, it is given to us that angle 1 is congruent to angle 4. So I'm going to go ahead and mark that in the picture for myself. Angle 1 is congruent to angle 4. And our goal is to prove that angle 2 is congruent to angle 3. All right, I'm going to go ahead and think through this process on how this will work before I start writing it. I know these angles are congruent. I want to prove these angles are congruent. Well, you'll notice right here, these are vertical angles. So angle 1 and angle 2 are going to have to be congruent. These are vertical angles. So angle 3 and angle 4 are going to have to be congruent. So if 1 and 4 are congruent, 2 is congruent to 1, 3 is congruent to 4, all 4 of these angles are going to be congruent to each other. So that includes angles 2 and 3, right? So let's start with the given. Angle 1 is congruent to angle 4 because it was given. Okay. I know angle 1 and angle 2 are congruent because they are vertical angles. So that is the vertical angles theorem that says vertical angles are congruent. I know angle 3 and angle 4 are congruent because, again, they're vertical angles, and vertical angles are congruent. Vertical angles theorem. And so now I can make the statement that angle 2 is congruent to angle 3. And all I have to do is substitute, right? I can replace angle 1 with angle 2, and I can replace angle 4 with angle 3, and I would have angle 2 is congruent to angle 3. All right, let's look at the next proof. We're doing several of these because I just want to provide you with several different scenarios and examples. Get your feet wet here since this is the first time we're doing this. All right, in example 5, line segment BA is congruent to line segment DE. B is the midpoint of line segment CA. Now remember, a midpoint splits something into two congruent halves, right? So this and this have to be congruent. And then D is the midpoint of line segment CE. So again, it's splitting this into two congruent halves. So these two have to be congruent. So now we want to prove that line segment CB is congruent to line segment CD. Well, if I follow the process of what I've just done, I've already got those two things marked congruent. So now I just got to lay this out into a proof. It should make sense why they're congruent. Alright, so I start with some given information. Line segment BA is congruent to line segment DE because it was given. Then they told me B is the midpoint of line segment CA. And as soon as I read that B was the midpoint of line segment CA, I knew that these two were congruent. So I'm going to say line segment BA and CB, those are congruent to each other. Sorry, I forgot to write given over here earlier. And the reason I know those are congruent was based on that word midpoint. So it was based on the definition of midpoint. Okay. I still have a third piece of given information here. D is the midpoint of line segment CE. Because D is the midpoint of line segment CE, I knew these two segments were congruent to each other. So I'm using this given information. And from that, I know that line segment CD is congruent to line segment DE. And again, that's based on the definition of midpoint, just like I did on the other one. Alright, and then my goal is to prove that line segment CB is congruent to line segment CD. Well, just like I did on that last problem, if I know these are congruent, I can replace one with the other, right? So CB goes in place of BA here, and then CD goes in place of DE right here. So I got CB equal to CD there. So line segment CB is congruent to line segment CD by using the substitution property. Alright, last one. We know that line P is perpendicular to line R. And we want to show that angle 1 and angle 2 are complementary angles. Okay, so I'm just going to think through this again. If these are perpendicular to each other, that means that where they intersect forms a right angle. So I know that these two lines are forming a right angle. Now that right angle is being split into two parts. Those two parts should have to add up to equal the whole, angle addition postulate, right? So whatever angle 1 and angle 2 are, they have to add up to 90 degrees. Well, that's what complementary means. Two angles that add up to 90 degrees or have a sum of 90 degrees. So there's the basic logical progression we're going to go through to write our proof. Now we just got to get it down on the paper. So we start out with line P being perpendicular to line R because it was given. Now, as soon as I knew that those were perpendicular, that's how I knew that this was a right angle, right? And this would be angle ABC. So angle ABC is a right angle, and that's based on the definition of perpendicular. Definition of perpendicular. My N kind of started floating way over here, didn't it? The definition of perpendicular. Now, if ABC, angle ABC is a right angle, that means that the measure of angle ABC is equal to 90 degrees. And that's based on the definition of a right angle. All right angles are 90 degrees. That's what a right angle is. Alright. So right here, angle ABC, the measure of that angle is equal to the sum of these two angle measures, angle 1 and angle 2. That's based on the angle addition postulate. Measure of angle 1 plus the measure of angle 2 equals the measure of angle ABC. Angle addition postulate. Now, since we know that the measure of angle ABC is 90 degrees, I'm going to replace measure of angle ABC with 90. I'm going to substitute it in. So I'm going to say the measure of angle 1 plus the measure of angle 2 equals 90 degrees. I did that by substitution. The substitution property. I replaced measure of angle ABC with 90 because those things were equal to each other. And now I have the statement saying that angle 1 and angle 2 add up to 90 degrees. So that means that they are complementary angles. Complementary angles, because that's what complementary angles are. It's based on the definition of complementary angles. It's based on the definition of complementary angles. The definition of complementary angles is the two angles that add up to 90 degrees. We got two angles that add up to 90 degrees up here. I know they're complementary because that's what complementary angles are.